This is BlockX3 website. And to open the website, you type human-friendly names called as domain names in the search bar of your browser. But the domain names are translated to IP addresses of the website server, which holds the actual content which need to be rendered on the browser. The job of translating domain names to IP addresses sounds very simple. But is it? You are about to understand the complete process of domain name to IP resolution, so buckle up, get your notebooks ready and rolling the intro. I am Anis, you are watching BlockX3, let's get started. We will talk in reference to this image which shows the process of DNS resolution. The DNS resolution starts with you. When you type the website you need to visit, your browser takes the domain name and using the stub resolver, it begins the process of DNS resolution. Stub resolver is an operating system component that is used to make DNS requests for application running on a computer. You can think of it as a library which helps the application running in the operating system to make DNS request. For the DNS server, stub resolver acts as a client which is making DNS request. The DNS request from stub resolver is sent to DNS recursive resolver. Considering there is no DNS proxy in between, the request directly reaches the recursive resolver. The name of this server is recursive resolver because it makes multiple recursive requests to finally resolve a single domain. The most common DNS resolvers are Cloudflare, which are 1.1.1.1, and Google Resolver, which is 8.8.8.8. The domain name is divided into two parts. The part after dot is called a top level domain, TLD, and the part before the dot is called domain. The domain name to IP address is a record, and the record of domain are held on a server which are called authoritative name servers. The server that holds the authoritative name server's location of a particular domain depends on the TLD of that domain, for example .com. So the IP address of the authoritative name server for every domain with the TLD.com will be stored on a server called TLD server. So it states that every different TLD, for example .me, .live, .xyz, will be different TLD servers. The DNS recursive resolver has the domain and it knows the TLD of the domain to be queried. So it must know the location of the TLD server. And since there are multiple TLD servers, the IP address of the TLD servers are provided by another server called as root name server. So the first request that recursive resolver makes is to a root name server to find out what is the IP address of TLD server. The second request is made to TLD server to get the IP of the authoritative name server of that particular domain. Remember the authoritative name server which actually holds the record of the domain name to IP translation. So the final request is made to authoritative name server and it returns the IP address of that domain, and then the resolver returns the IP address to the stub resolver, and finally your browser can make a request to that particular IP and get the content of the website. Most of you have used Cloudflare to manage your DNS. Here Cloudflare is the authoritative name server to your domain. When you buy a new domain, you change the name server of that domain to Cloudflare, which may look something like this. Now let's see everything in action because theory is not enough. We can use the dig command in Linux. If you are on Windows or Mac, you may search for a tool similar to dig in Linux. Using this command to see the DNS resolution process that recursive resolver does. As you can see, the first request is made to the root name server, which is denoted by a dot. Then it picks any one of the 13 available root servers to query for the TLD of XYZ. Again, it makes a request to this TLD server to ask about the authoritative name server. And finally, it makes a request to the authoritative name server, finds the IP address pointed by that domain and return to the stub resolver, which returns the result to the dig command. In most cases, if not all, the DNS request to the recursive resolver from your computer is not secured, which means the DNS requests are not encrypted. So if you are browsing while connected to an open network, your DNS query can be seen by anyone, which tells what websites you are browsing through that open network, which I think you do not want to let it happen. This is one use case where you need your own DNS server which can connect to recursive resolver like Cloudflare using TLS SSL for secure DNS query. Let us see how you can do that using your own private DNS server. If you want to run your private DNS server, you can use Technetium DNS server, which I use personally. You can run it on a Docker container. So if you have Docker installed on your system, you are good to go. And when you plan to run a container on a permanent basis, it's a good idea to create a separate network for it. I have created a separate network for hosting my permanent containers, which I have named local. You can use this command to create a separate network for your permanent containers. Now you can use this command to start a Docker container of Technetium DNS server. After the container is created, you can visit the IP address of that container, which in my case is 11.0.0.2, and the port number by default it's 5380. Now you will be asked to create a new password for it. After you have set a new password, your DNS server is ready now. The next thing you need to do is to go to setting and go to proxy and forwarders. Scroll down and you will see forwarders. From this drop down menu, select DNS over TLS. This will use Cloudflare DNS recursive resolver to query for DNS using TLS. So every DNS request will be encrypted. Scroll down and hit the save setting button. Once the setting is saved, you are now done setting up your DNS server. Now your DNS server is ready to receive requests. Now you can change your DNS server to point to this IP address of container. You can easily do it by editing the etcresolve.conf file in Linux. I have already set a name server of Technetium DNS server which I created earlier. We make videos in system design, DevOps, coding projects, web development, blockchain, and explaining tools and technologies. If this is something that you are looking for, then hey, there is a subscribe button, see down there, and see you in the next one.